In this tutorial, what we're going to do now is take a look at actually designing PCB for this particular circuit. So the way we're going to do that is we've got our circuit from before loaded up, we're quite happy with that, and what we're now going to do is click on this button just here, which is the Design PCB Wizard one. When the screen comes up, we can click on Next, and the option we're going to use is the one that says Rat's Nest. We're actually going to design this circuit ourselves from scratch. We're going to put a tick in the box just here, and then click on Next. On the next screen, what we're going to do is turn the size of the PCB up to its largest and click on Next and have a quick look through this list of all our parts. There's just one change we need to make at the current time, which is this, which is where it says LDR. It's got this 12mm LDR. We're actually going to change that from miniature LDR because that's the sort we use in school. Apart from that, I think everything else is okay. You'll notice that our piezo transducer here isn't ticked. That's fine, just leave that. I'm going to add that in manually a bit later on. So I'm going to click on Next. We're going to use standard PCB pads to make it easier to solve the circuit, and we're going to make sure we leave this box here unticked at the end. So we can then click on Convert, and we get a blank PCB with all of our parts, which I'm just going to pop up here for a second. And I might actually make that a little bit larger. The idea is going to be obviously to make this as small as possible, but just initially so we can see what we're doing, it's more helpful, I think, to have it looking like that. The view that we're going to work in to do this as well is going to be unpopulated view, this one just here, because then we can see through our components and it'll just make it easier to make sure that all our tracks are set up correctly. Let's start then by thinking about the process the same way we did in our circuit diagram. The first thing we've got in our circuit is we start with the battery, and the battery connects to the diode, which feeds the regulator. We'll put that in first. So in here somewhere, I'm going to zoom in a bit, I can see my power, it's got a plus and a minus on it. So I'm going to pick this up and stick this up here. Like so. After power, what we're going to need next is the diode, which is this part just here, so I'll put that alongside, making sure the two things aren't touching the components, they're not touching each other. And after that is the voltage regulator, which I'm going to stick again straight after, a bit like that. So I've got my three components side by side. I'm just going to roll the mouse wheel forward to zoom in a bit. There's a lot of labels on here that I don't want, so I'm just going to click on these carefully one at a time and delete them, just so I can see what I'm doing a bit more clearly when I'm setting out my tracks. You can see straight away that the way that the circuit is designed to work is at the positive end of the battery, connects to the anode on the diode. Okay, that's the positive end if you like, and after that it connects to the input on the voltage regulator, and then it shoots off to the next part of the circuit. Let's add these tracks now. What I'm also going to do is, rather than having these big thick tracks the Circuit Wizard wants me to use straight away by default, because we're a little bit better at electronics, I'm actually going to make it in slightly thinner tracks. So I'm going to delete that, and I'm going to double click on this track tool. Now, at the moment, on my particular Circuit Wizard, this is coming in millimeters. If yours doesn't, you can change it at any time by going to View, and then you can go to Grid and Snap, and you can set that to millimeters, which I'm just going to do now. I'm going to go to the nearest half a millimeter. And something else you can do as well is you can go into Project and Options, and in there you'll see Preferred Measurement Units, and again, just suggest you set that to millimeters. Anyway, back to where I was. Double clicking on here, my default track is about 1mm wide, which actually, now I think about it, is probably okay. I'm surprised. I think the default's actually bigger than that. So now I'm going to leave that on 1mm wide. So I'm drawing my track up a little bit like that just there. The next thing I have is the front end of the diode, which I'm going to bring up and connect in here like so. Because I've drawn these two tracks, I'm also going to delete the green line that goes with it as well, because that's the computer, trying to help me out. And I know I've done that now, so I can scrub those. Get my track tool again, and again just coming up diagonally and tucking in there into that end, which is 0 volts. Now that this is all done, I'm just going to put, just temporarily, a wire just running straight off here, which I know is my 5-volt rail, and I've got 5 volts there for wherever I need it. Because I want to be tidy as well, I'm just going to quickly add a pad, just a pad all by itself, which I'm going to pop up just about sort of, I don't know, here I should think. I'll probably move it later. When I've finished the whole PCB, I want to be able to drill some holes in it to actually mount it to the case of my alarm, and that's going to be one of my drill holes. So it's not going to have anything to do with the electronics, it's just purely there as a guide of where I need to drill. And before I'm finished, I'll need to sort of shrink this down as well to actually get the smallest possible PCB. But for now, I'll leave it be. Okay, what's next? So what I'm going to do now is zoom out again. Lots of zooming out to be done. And the next thing I want to pick up is actually the Genie chip itself, because that's the main kind of part of this circuit. So I'm going to pick that up. Let's just take a quick look and remind ourselves how this needs to be connected. On the circuit diagram, the Genie chip needs power. It needs a connection to ground, or 0 volts, or the negative end of the battery. And it also needs to be connected to a couple of inputs and a couple of outputs. The one I'll do first, though, is my power, which is pin 1, and my ground connection, which is pin number 8. Let's go and do that now. So pin number 1, if you recall, is you've got the notch like so, and pin number 1 will be right next to that there. Look, there's pin number 1, and pin number 8 is this one just here. I'm going to start by taking my Genie chip that I've got, zoom back out, and I'm going to pop that, not ultra close, but I'm going to put it fairly close, I think, to my 5 volts out like this. Okay, so that's looking a bit like that. I also need a connection to 0 volts, we said that already. I'm going to look at that momentarily. Before I do that though, what I'd also like to do is to remember one thing that you don't see on this circuit diagram just here, which is the download socket. I'm going to need to be able to push the actual program I write on the Genie chip onto the board. So I'm going to include a download socket, and the download socket is automatically added for us, it's just here. So I'm going to take that, I'm going to pop that up just a little bit above my Genie chip like this. Okay, and just temporarily I'm actually going to increase the size overall of my circuit board. When it comes to the download socket, we need to wire this up correctly. Let's look at how to do that now by going into the help file and looking in the help file at the bit about programming Genie microcontrollers and how to program a Genie C08. When you look at the circuit diagram, it actually shows you exactly how to do this. It shows us that we've got a connection to 0 volts that will be needed. That's to the left of it. That just goes straight down and straight into the battery, so that should be pretty easy. We need a connection to the status input on the Genie chip, which comes and goes into pin number 7. And then we need a connection to the programming input, which goes through a 22k resistor into pin 2, and from 100k down to 0 volts, a bit like that. So we'll need to include that. Let's pop that in there. So the first one I suppose is quite easy. That's the status output, which connects up just over here to this pin here. Look. So I'm going to grab a track and draw a track and straight down through the middle and straight into the chip. I also need this connection to my programming input over here through a 22k resistor. Let's go and find that 22k resistor. That'll be in here somewhere. There it is. There's my 22k. And I've got my 100k as well, like so. Okay, always zoom in. You see, I always do that. You should get into the habit of doing that as well. I'm just going to delete these R labels because I'm not sure how useful they are. I'm going to take my 22k resistor, and I know it's going to get down here, so I'm actually going to spin it 90 degrees, and I'm going to place it just there like that. So it's actually sat right next to, just about right on top of my download socket. Okay, just going to zoom in a little bit more. They're not touching, so that's okay, but they will be close in reality when I actually come to assemble this. I'm then going to draw a piece of track going from there, which is my programming input, into here, like so. So that's connected up. And once it's passed through there, it needs to get into pin number 2. And I'm going to do that by cutting through the inside of the Genie chip once again, like so, like this. Okay. What I'm also tempted to do as well, actually, just purely because if I can help it, I want to avoid the amount of distance that we have to cover inside the chip with those two things running parallel to one another. So I'm just going to sort of tuck those away a bit like that. How did that look so different? Oh, I see, this one's right slap bang in the middle. Yep, that looks okay. So I'm going to leave that like that. And the other thing it needs is, as well as a connection in there like that, it also needs a connection to 0 volts through a 100k resistor as well. I'm going to do that for it too. And the way I think I'm going to do that is like this. I'm going to move this up a little bit. And I'm going to move this. We'll need connecting back up. We'll need connecting back up. Yeah, so I'm going to connect this like it was. Keep connecting these back up so we don't lose them. It's very, very easy to lose these if you're not careful. And this one belonged to hold on. Yeah, that goes on there. There we go, back where we were. Right, and what I was also then going to do was take this 100k resistor and pop that alongside the first one, a little bit lower down there. Okay. Okay, what I'm then going to do then is, because I've got my 22K connection going in here, I've got my 100K connection, which I'm going to draw from here straight down into this one, and from here it needs a connection to 0 volts. So let's see if we can find that somewhere. 0 volts, the negative end of the battery, is anywhere along this wire just here. So as long as I can get it to there, I can do it fairly cleanly, and I've got a good solution. Let's see if I can do that now. So I'm just going to come out, down, along a bit, and tuck that in there like that. So that's connected to the negative end of the battery ultimately. Let's try some more. Delete a few of these green wires along the way. When you do delete the green wires, you have to right click on them. You can't left click on them, then right click on them. That never seems to work. You just have to sort of right click on them straight away and it will select them so you can scrub those out. Like that. Okay, so those are in there. The final connection that I need is a connection from this pin here. That goes to ground. So as long as I take a connection from here to 0 volts, I'm good. So for that, we'll go out of here, out a bit, and then straight in there. So that's connected to 0 volts as well. This one here now needs to be moved up a little bit because that's kind of taken up a lot of space now. And I imagine before I'm finished, what I'll probably want to do is actually move these 3 components here right up, so I'm not wasting any space. We should perhaps actually look at that now, because otherwise it'll be much more difficult later. So let's do that now. Let's take this pad and shift that up. Let's take our power and shift that up as well. Like so. Let's take our diode and move that up too. Oh, that's not been very helpful today. Like so. And let's take our voltage regulator and let's move this up as well. And keep it quite close to all the other components as well, I think. It's not very helpful that the wires aren't moved. Normally in Circuit Wizard, what happens is all the components get moved for you automatically, so all the tracks where you've linked them all in. For some reason, that doesn't seem to be happening today. I guess it's because I turned all the measurements to metric, but that's all right. I can remember how it went together. We'll sort it. So that one went there. Positive went up there. From here, it went into here, because that's the input leg. That's right. And this one here was a connection to 0 volts, so that's going to go there. Extra node there, just to pull that into a nice, neat, tidy line. Negative end of the battery, that got connected up like this. There we go, that's that bit. That's that bit. This was a connection to 0 volts, wasn't it? Yes, it was. So from here, this is all 0 volts now, so just go straight up there. Like so. Oops, no, that wasn't a connection to 0 volts, that was. What else do we have? This here needs 5 volts in order to work properly. 5 volts is currently living up here somewhere. Ooh, made a bit of a tricky problem for myself here. I'm sure we can sort this thing. I'm going to do that by going like that. Something like that, I think. That looks alright. I'm going to come from here, out, down, out, down, down a bit more, and nearly. Let's just pull that up there, and pull that up there, and again, just because I like the angles, have that a bit of a 45-degree angle like that. Okay, that looks pretty good. That's quite nice and close too. What else can we do? Again, you've always got to be thinking, how can I make this a little bit smaller, a little bit smaller, a little bit smaller? That's the game you're constantly playing with circuit design. So I've just moved that closer still. Trying to make it so that it doesn't actually touch the next bit, the next track. Let's see, it's the compromise. There you go, that looks okay. If that moves to there, then that can probably move up a bit. Keep jiggling things around. That's going to move into there. Now it's going to move into there. We need to tidy up into there. Oh, this might cause a little problem here. Sure, we're going to sort this out. Okay. If you just do what I'm doing, we'll be there in no time as well. There we go. That's good. There we go. Good. See, so already we're making the overall actual design for our circuit much, much smaller. Okay, what else do we need to add in? Well, I suppose the next thing we better do is give this its connection to 0 volts that it wants. So let's do that. So what's a good route to get to 0 volts? We could skip around the bottom, but we've got all these extra pads just here we need to solder onto. So that's probably not a great way of going about doing it. A little shortcut I've picked up, that I use all the time for this, is to go a bit like this. I come out like that. I then come up the outside edge, up to here, sneak through here. Look, you can pass this right through here, which is absolutely great. And then from there, you can just dump it straight into there, because that's going to 0 volts. Okay, like so. So yeah, don't be scared to do that. That's a lovely little way of getting around it. All these things are miles away from any of the other pads, so that's absolutely fine. That just gives us a really, really neat way of getting down to 0 volts. Okay, let's look at our circuit diagram and work out what to do next. Okay, next thing, so we've done this, we've done this, we've done this, we've done this. We're actually not all that far from finished, as you'll come to realise in a second. Next thing I want to do then is to try and get this LDR. Let's have a look at that. That needs to go into pin number 6, and the push to make switch goes into pin number 4, pin 4 and 6, which will be the easiest for me to look at first. Well, pin 4 is this one, pin 6 is this one. Let's have a look at what needs to go into pin 7 and pin 2 first, I think. Let's deal with those, pin 7 and pin 2. So let's go shopping. That is pin 7. Okay, so pin 7's got a resistor and an LED. That should be pretty easy. Pin 2. Okay, there's pin 2. Just hello. That's actually telling me that's no. Okay, it's not that one. Let's leave that for a sec. That's pin 3. Therefore, that must be pin number 2 there. It's got to be that one. Just going to try and slide that resistor along a bit, just so I can see it. No, it's pin 5 actually. That's interesting. I thought I was using pin 2 somewhere. Oh no, pin 2 is already used, isn't it? Because pin 2 is the programming input. Okay, what about pin 3 in that case? Which one was pin 3? Let's start from the left and work over to the right. Pin 3 we decided was this one here, is this LED, okay? Output 4 is pin 3. So it needs a resistor and an LED. Let's do that now. So first thing to do is to go and grab a couple of components. So I've got an LED just here. The computer actually wants this LED to go onto this output. It might argue really, I'll let it have that if it really, really wants it. And which one does this one want? Oh, hold on, it's doing that because there's those 330 ohm resistors it wants as well. Let's go and see which one's which. Okay, the computer thinks that we should be using this resistor to go over this side of the board. And this LED. So let's let it do that. I'm not going to argue. And let's let it use this resistor and this LED over here. In reality, it doesn't actually matter. You can connect it up how you like. Circuit Wizard's just trying to be helpful. But just for today, for this, I'm going to do it this way. Now, we've got a choice with this. We can either go resistor then LED, or we can go LED then resistor. I'm inclined... let's try LED first, and we'll just see how it shakes out. Okay. With the LED, let's not forget you've got a positive end and a negative end. Okay. So your positive end is just here, your anode, and your cathode, your negative end, is over here. The GD chip pumps out positive. Okay. So I need to connect this end to this end. I'm going to do that by placing my resistor here, really, really, really close to, and actually lining it up rather close like that. Okay. In reality, my LED is actually going to go on a piece of wire, which is going to shoot off and be over here somewhere. So it doesn't matter really if my white sort of shape overlaps anything else. Let's draw some track then. I'm going to go from pin 3 to the positive end of the LED, like so. And then from the negative end of the LED, it's going to go through this resistor, which I can place quite sort of close, a bit like that. Connect that one to that one. And then from 330 ohms, let's have a look. Goes to the negative end of the battery. goes to 0 volts. Right, where's 0 volts at the moment? 0 volts is quite a long way away actually, because I need to get to here. Look, I need to get this into here. Or I can get it to there, which involves drawing a big old loop right around the outside. I'm a bit reluctant to do that. What else could I do? Well, another thing I could do instead is I could rotate this 90 degrees and I could plonk it sort of in here. Does that help me a bit? Yes, I think it does. I can plonk it in here. It's not touching anything else because we said this LED won't actually be here, so it's just going to be 2 wires sticking out of the board. I can plonk it like this. And the reason this helps is because I can send this wire into here. It then jumps over the track and I connect it to here, which takes me to 0 volts. Rather a neat solution. Let's do that. Once again, labels getting in the way, so I'm actually going to delete those just to clear things up a little bit. And I'm going to take another node, take that into there, and take that into there like so. That's looking good. Then run another piece of wire from here straight into my 0 volts end like so. Right, that looks pretty good. I wonder what else I can do at this point. I'm now kind of thinking, everyone my little, can we make it a bit smaller, can we make it a bit smaller sort of train of thought. I'm wondering if I go like that, I can actually move this up a bit, which means I can move that up a bit. That'll save me a little bit more space. That's a neat thing to do. Looking good. Right, what's next? More labels, just do some more delete. Okay, what's next? We've done pin number 3. Pin number 3, and that was one of these LEDs, wasn't it? Do that one? Yeah, we've done that. Okay, what's next? So what we should do next is let's try pin number 7, which is another LED. So let's go and do the same sort of idea all over again. LED or resistor first. I'm not sure this time. Let's try the resistor first this time. I'm going to stick that here, so that's just sort of running nice and neatly parallel to where I am at the moment. And I'm going to grab my track tool and bring that out. It needs to come up just a little bit to connect that in there like so. Once it's gone to there, it then needs to connect to an LED. LED can sit up here somewhere. There's the positive end of the LED. Just zoom in again so I can see what I'm doing neatly. There we go, like that perhaps. And I'm going to grab the track tool, connect from here to here, and from the negative end of the LED, that will come out, and that'll jump in here, look like so. Now, it's about this time that I'm kind of thinking to myself that actually that's okay, but this and this, they're very, very, very close, and that might cause me a little problem down the line. I'm sort of wondering if I can go that way a bit. I could, but now these two are really close. What should I do? I could just move the LED out, stop being so mean with space. Could do that. Let's do that. Okay, looking good there. And I'm going to bring this one back out again. Just purely because all that little extra bit of space will just make it easier to solder it all together when it's done. Okay, so that's that one. Delete some more labels, just so it's nice and clean. Delete some green lines, because I'm kind of happy that I've got those done as well. And they annoy me a bit when I'm trying to see what I'm doing. Okay. What's next? Next thing I suppose we want to do is look at pin number 6 and pin number 4. Either 6 or 4. Let's do 4. 4 sounds good. Pin number 6 is the LDR. Pin number 4 is the push-to-make switch. So let's look at this push-to-make switch. The switch takes its power from the 5 volts end, so we've got here, the 5 volt rail. The other end of the switch goes into the Genie chip on pin 4. And pin 4 of the Genie chip is also connected through a 10k resistor to 0 volts. Let's go and do that then. So my switch, that's my switch just there, floating around here somewhere, will be a 10k resistor. There it is. And let's connect that up. Okay. So we said that we need with this switch, again sit that in quite close, a bit like that perhaps. With the switch, one end of the switch needs power, we said. Okay, where have I got 5 volts? I've got 5 volts here, coming all the way down and around now. So that's okay, I can take that straight away then. And I'll go out just a little bit to make sure I don't get too close to that one. and then feed that straight in there. So that's 5 volts gone in there. The bottom of the switch goes into pin number 4. That's looking good. And then pin number 4 through the 10k resistor goes to 0 volts. And I had a bit of a hard time finding 0 volts before. What did we end up doing? We've got 0 volts up here, 0 volts here. I haven't really got a convenient place to get 0 volts from. What I should have done, I kind of reflect now, I should have kind of left a way I could get 0 volts up and around the top. I'm reluctant now to make my board any bigger. What I'll do is I'll go and run a track from here into just here, a bit like this. Okay, like so. And what I'll then do is I'll take the other end and I'll actually bring that round and I'm going to sweep it right around the outside and I'm going to connect it up here. And when I've finished, I think what I'll do is I'll make it so that the last thing that I do is just to minimise that, to make it as small as I possibly can. So at the moment it's huge, but it's huge so I know it's there, so I know I can shrink it when I'm done. I'll build everything else inside that space. What's left next? I need to connect up something onto pin number 5 and pin number 6. Let's bring these components up here now, and I'm a little bit closer to them. Picking those all up. Okay. Right, my next one is, let's have a look, what's the LDR? Pin 6. Okay, so for the LDR, the one end of the LDR takes a feed from 5 volts, the other end of the LDR goes into pin 6, and then from pin 6 through a 10k resistor to 0 volts. Let's give that a go. So, pin number 6. Can I find some voltage somewhere? Where do I get 5 volts from? 5 volts comes from here, can't get that to there. Comes down here. I could probably sneak it through that gap actually and take that in there. That would work pretty good. Let's give that a try first of all. So, track tool, and then from here out a bit of diagonal, I think. A bit more diagonal still yet. Looking good. Bring it back up, just to not waste any space. Connect it like that. Yeah, that'll be okay. And then into there, so that's into the bottom of the LDR. Other end of the LDR feeds it with power like that. And then finally from that pin through a 10k resistor, which can be U. There, down to 0 volts. And let's just slide that out a bit so those two things aren't touching. Looking good. Okay, so that's connected up quite neatly. Quite pleased with that, I think. It's on 10k volts to 0 volts, so you're going to end up connected up like that. Right, okay, all we've got left is our transistor and our piezo transducer buzzer, which I suppose we'd better stick in now, actually, before we get too much further down the line. The piezo transducer buzzer is obtained by going to output components, band audio, and you'll see it there. Piezo transducer crystal is this thing just here. Now, the first thing you notice is it's ginormous. Okay, yes it is. I completely acknowledge that. And given how lovely and compact and tiny the rest of the board is, it is going to take up a bit of space. Okay, not much we can really do about that, but we can try and minimise its impact a bit. What can we do to try and bury that a little bit? We could attempt to sort of stick it here. And move all the other components around to this bit of space. I'd be tempted to do that. I think what we'll do, for the purposes of this tutorial, is I'm just going to sort of squidge that in anywhere, and then for the actual PCB you end up making, I'll move the parts around a little bit, and we'll see what we can do. I mean, it's been nearly half an hour already, hasn't it? So let's just press on for a second. We'll come to this now. Let's look at how the transistor bit works. For the transistor, we need to go from pin number 5 through a 1k resistor into pin 3 of the transistor. Let's just look at that and nothing else at the moment, okay? So, 1k resistor from here. Let's look at how we're going to do that. Now, we've kind of used up quite a bit of space, or sort of used up quite a lot of space, really, kind of hemming all this in. So I'm actually going to need to move my LDR out even more. I'm going to move my 1k resistor out even more, my 10k resistor, sorry, so that I've got space to squeeze you in just there, like that. Delete some more labels so we can see what we're doing. Like so. Add some more greenery as well. bit more greenery, and a bit more greenery. Okay, I'll leave that actually temporarily. Okay, so we'll connect up our track a bit like this. We'll move this so where it actually belongs in the first place, which is on here. Or actually, maybe even just here. And we put you back on. Alrighty. We decided that the 1K end of this, the base, if you will, needs to be connected on here. So let's do that. Spin that around by 90 degrees, I think, and replace that physical component just here, if I can. Might have to move it. And let's get a track running from here into there, like so. What we then have is we've got the other two parts. Now the emitter just connects down to 0 volts, so we can handle that pretty easy as well. The emitter on this particular one is pin number 1, so let's connect you down there. Okay. And the one that then remains is the collector. Now let's look at how we connect up the collector. For the collector, it needs a feed from the positive end, or actually from the other end of the diode, if you want to be really specific about it. It needs to go from the diode to the top of the piezo transducer buzzer. Let's have a look at how we're going to do that. Now, I can't remember which one's positive, it's this one. Let's have a look. That's not too bad. We can get the 9 volts breaking out of here. We can come down here, nip in down sort of diagonally like that. That's looking good. So we've got 9 volts on there. That's lovely. That can come down, and that can come along. And let's see if we can squeeze it in somewhere abouts around here. You see, if I take this piezo transducer buzzer, if I rotate it anti-clockwise 90 degrees, I can actually have part of it here, like that. And I can have the other part of it connecting to 0 volts. So how about that look? Like so. That's not quite right there, is it? It doesn't connect to 0 volts. The negative end connects to here. So I'm going to actually tuck you out of the way. I'll beat all that up in a minute. Why don't we do that either? Let's see. Just delete that. Right, that end there does need to go to 0 volts, and I'm going to connect it up like that. The reason is I need to be able to go from here down and into there like that. Now that'll work. There we go. But actually, that at the moment, if I just left that and etched that as a circuit, that would now work. I could plug this in, fire it up, and I can make that work. There's a few loose ends we need to tidy up here, though. One of them is this is needlessly far out, so I'm actually going to bring that right in, like so, which kind of helps, reduces the overall size quite a bit. Also, Control Z, bring you in, like so. Also, I can probably come in rather a lot with that. With that there. That to there, like so. That can slide back a good old bit as well. That can go there. And that can go there. Just keep adding nodes, look, just to get it all nice and neat. And that can go something a bit like that. Probably pull that a bit straighter. You don't really want that at an angle. Or like that for that matter. There we go. Right. Okay, how's that looking? Not too bad. Straighten things up a little bit. Okay, the next thing we can do then is we can stick our corner pads in. Now, let's have a look. Realistically, that would go about there. That would probably go about sort of there. And the last one will go there. There it is. We can then tuck in all our corners. Shrink down the overall size. Make sure there's room for the actual piezo transducer on the board. and then zoom in a bit. So, if we look at this, am I kind of pleased with this? Well, overall, actually, I've got to say, I don't think this is too bad. The main area when you look at a PCB, where you try to evaluate whether or not it was any good, is where you look at how wasteful you were on space, at the end. And in fairness, I don't think that was all that bad a design. We could do little things, like I'm doing right now, look, just to try and wheedle some space down, but none of this actually makes the board any smaller or thinner when it's finished. So it's a kind of limited value, really. But, it makes me kind of feel good about sort of doing it in this way. I can't. This is the big limiting factor. If I wanted to try and make this board smaller, which is what I encourage you to do, what I would also try and do now is I would see if I can do anything to do away with all this wasted space here by getting this piezo transducer to go somewhere else. If I was going to do this again from scratch, I'd actually place the piezo transducer first, and I'd probably stick it down here somewhere, and I'd build the rest of my board around that. The other thing that needs to happen before this is finished is we need to put some labels in. Okay, don't forget the labels. And the useful places to put labels are where it's not always convenient to have labels. What I mean by that, for example, is just here. This is pin 1 on the Genie chip. When you look at this artwork, you hold it in your hand as a PCB. At the moment, it would look like this. Okay, very, very unhelpful because it's so densely packed. What would be much more helpful on the artwork is if you've got a nice little number 1. Just here, look, I've got a number 1 there. And I'm actually going to change the font on that. Just going to change it back to size 6 font. That's the smallest font size really you can get away with. And I'm also going to turn off the grid snapping as well with that. It just means that I can really, really finely control it. It now means that when I do hold that in my hand, my artwork, I'm just going to copy that one and paste it now as well. I can, get an idea of what I'm looking at. So I might want to label that as a CO8, for example. So that's labelled in there. It's a mirror image, it will be, but when it's actually manufactured, it'll be the right way around. What else could be useful as well to label up? I'd probably want to label which one of these, this is my voltage regulator, look, which one of these was output. So I'm actually going to paste one of these here and put +5 on here. So I know that's +5 volts, that's the output from the voltage ramp. What else would be a useful one to do? This is an LED, it's the positive end, so I might be tempted if I can squeeze one in just to put a little plus and just tuck that right in there so I know which end is a positive end. This here is a 330 ohm resistor, so again with these I tend to get in there and I label that up. And I label that as 330, you don't have to put anything else in there other than that, and because it's sideways on, when I look at it I know that it sort of flows between these 2 points just here, so that's useful to do. What else have we got in here? That is the LDR, so I might be tempted if I can to get LDR nearby. That might not be appropriate to do that here. There we go, that's not too bad. Again, those two things are quite close now, you see, and that's when you start risking soldering problems, when you actually build it all up. So I'm going to move that as close as I dare over there. What else have we got in here? I've got another resistor, this one's a 10k, so I might be tempted to put 10k in here. Again, just turn it sideways. 10k, I wonder if I can get that in there. Probably just about can. Again, very, very, very close. So that's there. And so on. The final thing you'll want to do, once you've got all your labels in, is to, of course, as well, make sure you actually say on the board somewhere what it is and what it does. Okay, like so. So, to sum up, it's been a long way, but I think we've got there in the end and made a pretty good one. That is how we design the PCB for the drawer alarm. Hello, don't be doing that. That is how we design the PCB for the drawer alarm in Circuit Wizard. In the next program, what we're going to need to look at is how we can actually write the program code for this in BASIC. What I think I'll also do before you come to this as well is I'm going to go and see if I can improve my PCB and make it a little bit smaller. After I finished the last tutorial, I had a quick play around and moved some bits around. I've actually come up with this design just here, which is very similar to what we did before. The main differences are I moved a lot of this stuff up a little bit more and tucked that in slightly. I moved the piezo transducer over to the left. What else did I do? That was about it, actually. There's one thing I had to do that I wasn't overly keen on, which was just here on this LDR. I've made one of these tracks. I made it a lot thinner. You can always do that by double-clicking on the track. And I set that down to 0.5 millimeter thick, which is the same thickness as these borders look around the outside here. So when I make the board, I've got to be really careful. The other thing about that, of course, is because I snuck it between, let's zoom right in, I snuck it between two of the the legs on the Genie chip as well, which means that when you come to solder this together, it'll be very easy to short these two wires together. So you've got to be really, really careful when soldering, just to make sure that you don't accidentally do that, because otherwise you're going to have a real problem with actually putting the board together. So keep an eye out for that one. Something else I meant to mention as well was that when you are doing this, you can come into this drop-down list over here on the right-hand side, and you'll see you've got the various power supplies available. One of the things that I want for us to do is to grab the 9-volt battery, so I can actually test this, and I'm going to click here to put that in place. Now, when you do that, what's going to happen is it looks like the battery disappeared, but that's okay. That's just because you need to change the view back to either current view or real world view before you can actually see it. Once you've done that, we can then grab and draw a line from power onto the power end of the terminal, and we can draw one here to the negative end of the battery. The other thing you're going to want to do as well is you're going to need to come here into your switches and grab a push to make switch, and plop that there. I'm going to flick that upside down. Once that's in place, I can also connect my switch just like I'm going to connect it on the actual circuit itself, like so. It's going to go on there, and it then means that when I actually want to run the circuit, I can flick over to current view, click on play, ignore that, and you can actually see the electricity flowing through the circuit. It also means that you can see me arming the circuit by clicking and holding my finger on the button. You can actually watch all the individual components start to flash on and off. Okay, and again, it's just a really handy way to make sure that if you were to manufacture this and make it using the etch tank, that you knew that the end result would actually work properly. So yeah, make sure you do that as well at some point, just so that you know your actual circuit's going to work. You see here, look, the piezo sounder getting its energy, look, as it discharges. So then you know that that would work. Okay, so yeah, that's all I wanted to show you really, and I'll see you in the next tutorial.